Hello everyone, my name is Sriram and this is Software Engineering Web-Based System class course number CS6320. I'm going to discuss about my project. My project is on uh, various approaches for optimal performance evaluation of e-commerce web application using queuing network model. So I'm going to give you a brief introduction about my project. So I'm going to talk about e-commerce. So what is e-commerce? E-commerce is a successful trading business in products or service using computer networks such as internet. So what technologies does e-commerce handle? It handles mobile commerce, electronic fund transfer, supply chain management, online banking, online transaction. So everything is based upon a web application. So more or less it is like web application. So it covers a range of different types of varieties in a business. So what does a web application plays a role in e-commerce? Well, a web application plays a vital role in e-commerce business. By using a web application tool, it maximizes the functionality, power and flexibility of an e-commerce application. So I'm going to use a tool with a model called queuing network model. So what does it do? It evaluates the performance of the web application, and it optimizes or it improves the performance of the web application. So now I'm going to discuss the concept of queuing network. So what does the queuing network means? So the base concept of queuing network is to analyze and design for the computer system and to evaluate performance of a job. Evaluation is based upon some strategies. So what are they? Your utilization, residence time, queue length, and throughput. Using queuing network model, performance evaluation of web application or a software model will be 5 to 10% accurate for a utilization or and throughput, and 10 to 30% accurate for a response time. Now we are going to see about a basic structure of queuing models. So this is the diagrammatic description of a basic structure of queuing model. So what does it has? It has an input source, queuing system, and served customers. So what is an input source? Input source, or otherwise called calling population. The size of a total number of customers. It may be finite or infinite. They are arrival customers. So these are called input source. The customers who are arriving and who are standing in a queue are called input source or a calling population. What is a queue? Queue is where customers wait before being served. Queue is queue may be infinite or finite. What is queue discipline? Queue discipline is a member of queues is order in which a member of the queue are selected for service. So it has a criteria. So it is based upon a first come and first serve, first come and first serve in uh, normally used. Here you are going to see about a service mechanism. So what is service mechanism? Service mechanism is to facilitate the service which contains one or more parallel channels called servers in our case, which the customer enters one parallel service channel and is served by the server. Service time is usually defined by a probability distribution. And below here are the terminology and notation for a queuing theory. And this is the relationship between low workload and load queue and workload intensity. Here is an example problem to solve to find arrival rate for a minute. So here let's say lambda is equal to 1 customer per 10 minutes, then it is 0.10 customer for a minute or 6 customers for an hour. So inter arrival time between a customer is 1 by lambda. So the service time takes 30 minutes on an average. So what is the service rate per minute? Mu is equal to 1 customer by 30 minutes is equal to 0.0333 customers per minute or 2 customers for an hour. So service time is 1 by mu. Similarly, there is a calculation for utilization to find out the utilization. Suppose lambda is equal to 6 customers of an hour and mu is equal to 2 customers of an hour, then the utilization pi will be lambda by s into mu, where s is a server. So here you have one server, then it is 6 by 2, 2 into 1, it is 3. So utilization is greater than 1, so the steady state will never reach the queue length, so it will increase and goes to infinite. Similarly, if s is equal to 3, again the utilization will be 1 and the queue is unstable, may or may not reach the steady state. Again, it is not conformed. So if there are 4 servers, then it is 3 by 4, which is the utilization is less than 1. The queue will reach the steady state and the line or the queue will be in a finite state. And here there are types of queuing model, queuing network, types of queuing networks. So here there are 2 types of queuing networks. One is single service center, another one is multi-service center. So what is a single service center? The diagrammatic description of single service center is like arriving customer in a queue, and you have a server which serves for the customer, and the other arrow is for departing customers. Served customers are then departed. So this model has 2 parameters. One is like workload intensity, which is the rate at which the customer arrives, and other one is service demand, the average service required for our customers. And here is the graph analysis for a single service center using utilization and resident time values. Similarly for queue length and throughput values. So now we are going to discuss about the attributes of queuing network model. So it has a set of quality attributes. So now we can see the first attribute. First attribute is about the rate at which the customer arrives. Is only one of 3 means to describe a workload intensity. So example is transaction process workload, and the second attribute is a state the number of customers in a model, and the example is batch workload. And the third attribute approach says that state the number of customers and the average time for each customers between interaction. So that is between interaction, and the example is interactive workload. Queuing parameterization. So what is queuing parameterization? The parameterization of queuing network is made by an assumption. Suppose if you want to calculate a device demand for a customer in a CPU device demand for a customer in a queuing network, of a current system, and we can observe by two operations. One is the number of seconds that CPU was busy, and two is the number of user requests that were processed. Example: transaction, interaction, or jobs. Then divide the busy time by the number of request completion to determine the average number of seconds of CPU service attributed on each request. Modification analysis, you have two effects, one is like primary and one is like secondary. So based upon this effects, the parameters have been implemented or changed. Evaluation, there are two approaches for an evaluation. One is to calculating performance measure and to evaluate the value of performance measure. So an algorithm should be extremely efficient for this evaluation, especially the running time. Here you're going to see a different approaches to optimal performance of e-commerce web application using queuing network. The base concept of queuing networks is to analyze, to evaluate, and to improve the performance of complex behavior of a system. So e-commerce is on a web system is one of the complex system behavior, and there are different queuing model approaches addressed in many studies gives a resolve this complex system behavior using a queuing network. So we are going to see some of them. First is Almeida. Almeida is a scholar who addressed a paper or research. It's about a model that identifies a optimal resource allocation by providers maximizing revenue and satisfying customer QoS quality service constraint and minimizing the resource usage cost. Here he has two interrelated problems. One is like short-term resource allocation and one is like long-term resource allocation. So finally, he applied a queuing network model in his resource management problem, and the final result are the larger problem size is resolved in 15 seconds, and it proves that it is implicable for online, and the optimization model can sublet a total cost of saving of provider as much as 39%. The resource cost is reduced to 39%. Then Zhong Li, another scholar, he addressed queuing networks in his paper. So he proposed a method of maximizing the profit in a general class e-commerce environment. So the use of generalized processor sharing, closed queuing model with a multi-class for servers, and formulated service legal agreement between a service provider and clients. But there is a disadvantage. As the delay experienced by the customer, the business results in loss of revenue. So for this, we applied a constructed optimization problem based on queuing theoretic formulas, and the final experiment result are they solve the problem via fixed point iteration. This maximizes the profit of SLA in e-commerce environment. Urganka proposes about his novel dynamic provisioning technique for multi-tier internet application. This is to determine resource to allocate at each tier of application, the combination of predictive and the reactive method. So again he applied a queuing technique, open queuing technique based upon GG1 model. So what it does, it doubles the three-tier application workload, and the experiment result is to maintain the response time target. The overhead of switching server across application is reduced from minutes to less than a second. Then Boon is another scholar who addressed a queuing network in his proposal. It's about an adaptive load balancing strategy called SALSA, Simulated Annealing Load Spreading Algorithm, where he used a queuing theory, standard queuing theory, to derive average waiting time, and the experimental result is that the simulated annealing load spreading algorithm has the ability to determine dynamically adapt its load balancing strategy. So as you see, a lot of people have addressed a queuing network on their paper to resolve their problems, and it paid them in a better way, and the final product result was it was more productive and efficient and higher than the previous one. So I suggest a queuing network is a very vital or primary for the web application, especially for the e-commerce web application. And here is the annotated bibliography. Uh, Thank you. I hope you have enjoyed this video and you have understood the concept of queuing network and its advantages. I hope you enjoyed. Thank you.